Okay, this is grade 12, November 2021, paper 1, question 2. And this is a sequence and series question. All right, a geometric series is x plus 90 plus 81. Let's take a minute to talk about the difference between a sequence, which is a list of numbers. So in this case, the corresponding sequence would be x, 90, 81, and so on. And the series, the difference is that we have a plus sign between them. We are actually adding the numbers. So if we consider a value in the sequence, we would say a sub 3 is 81. But if we were looking at the sum, we would say s sub 3 is x plus 90 plus 81, the sum of the first three series. And I would call n, in this case, 3. Okay, so looking at this geometric series, the term geometric means that each term is multiplied by a value, usually called r, which stands for ratio, to get the next term. So I know that x times r is equal to 90, and 90 times r is equal to 81. So that allows us to find the r value, which would be 81 divided by 90, which is 0.9. That's our r value, or our ratio. And then that would allow us to find the x. And in this case, the x will be 100. So that's our first term. We often call the first term a, or a sub 1, and that is 100. In this case, it's also equal to x. Okay, 2.2, show that the sum of the first n terms is s sub n equals, and they give us what they want us to have. So this reminds me of a formula on the formula sheet. And I pulled this from there. And we want to try to end with what they have, which is 1,000, 1 minus 0.9 to the n. So that's not exactly the same form as this formula, so we're going to use the formula to get there. So s sub n is equal to a, well, that's the first term, and that was 100. R, we know, was the 0.9, and we have r again in the denominator, 0.9 minus 1. So our job is to get this to look like what they have. So I notice I can add those two numbers in the denominator, just copying, and then I get a negative 0.1, and those can be combined, the 100 and the negative 0.1, and that will give us a negative 1,000. You could do that on your calculator, but you might know how to do that without that. And now we're very, very close. We just noticed that we have a negative 1,000 instead of a positive, and our terms inside the parentheses are just going to be the opposite. So we can actually distribute that negative and swap these terms inside, and we have it. Okay, let's continue with 2.3. 2.3, they ask for the sum to infinity, and that reminds me of another formula. Sum to infinity is equal to a over 1 minus r. This only works when r is between negative 1 and 1. So what that means is if we added all the terms 100 plus 90 plus 81, and so on, and we went on and on forever, that's what equals the sum of all the terms. So it's a nice simple formula we can use. Again, A was equal to 100, and the R value is what we multiply by to get from one term to the next. We figured those out in the previous two problems, so we know that A is 100 and R is 0.9, so we get 100 divided by 0.1, which is 1,000. Now that shouldn't surprise us. If we look back at S sub n and we think of the limit as n goes to infinity, that should equal S sub infinity. So the limit as n goes to infinity of 1,000 times 1 minus 0.9 to the n will be equal to 1,000. You don't have to do it that way, but you can think of it that way. Okay, all finished.